Good morning students, in this video we will discuss elementary discussion on safety devices. In the electrical point of view, we are having so many safety devices like MCB, fuse, circuit breakers, and also like relay coils and all, right? And also we are going to discuss electrical shock and its precautions. I think this is general concept. Knowledge directly in your pocket, not marks. Definitely knowledge will be directly you can keep in your pocket. Instead of saying marks, I'll tell you. So topic is very general, right? First, one by one we will see elementary discussion of safety devices. Anybody having a guess? Like what are the type of fuses are present? Here KitKat fuse will be there, and there is a normal fuse. I'll show you in the laboratory all the fuses. If suppose the fault occurs, if suppose short circuit occurs, if suppose something abnormal condition occurs, automatically this fuse will get melt. They used to keep fuse wire by here, and here also they'll keep on thin wire. So if suppose short circuit occurs, automatically that wire will get melt. This is MCB, mini circuit breaker or miniature circuit breaker. When fault occurs, when short circuit condition occurs, automatically that will get trip off, right? So that is the MCB. So only two safety devices we are having, and also earthing also present. We will discuss in the next video, but we will discuss these two now, and also electrical shock. What is the meaning of fuse? A weak link, one thin wire is connected between two terminals. If suppose fault occurs, current exceeded limit, automatically that fuse will get melt. When, at what time? Fault condition time, short circuit time, and abnormal condition time, right? That is called as a fuse. What is the purpose of fuse? Why we are using that fuse? If suppose there is an abnormal condition, short circuit condition in the TV or refrigerator or washing machine, if there is a fault in the one equipment, automatically that short circuit current sensed by that fuse wire, right? So fuse will get melt because 2 amps only we are using. If it is 2 amps reaches, automatically that fuse will get melt. It will not continue. It will not affect it to other electrical appliances. If it is fuse is not working, fuse the wire will not get melt. Definitely the other equipments also will damage. To avoiding the damage, we are having a fuse. Okay. And it's a simplest protected device, fuse, invented by Thomas Alva Edison in 1880. And working principle is H is equal to I square RT. H is the heat, I is the time, I is the current, R is the resistance, T is the time taken for heating up, or time taken for blowing off. Burning out that fuse. This is another fuse. You can see here in the circuit or anywhere. If you see these things, definitely you just remember this slide. So sir has given some ideas, some information regarding this fuse and all. So these are all the fuse. Okay. So first one is okay. Characteristics of one is good conductivity and low melting point, low cost, non-deterioration due to oxidations, and necessity of fuse. The necessity in a sense, the whatever we are using right at fuse wire, that must be like thin and then having a low resistance. Because if you have a high resistance, definitely the fuse will not get melt. Automatically that it will affect it to all the electrical appliances. Okay, so that's why. And also the if it is heat increases, automatically that fuse will get melt. You should use thin wire. Okay, and melting point also like low. And rated current carrying, so normal working condition, rated, and then fusing current, abnormal working condition. If suppose 2 amps will be there, rated current, without any fuse wire burning out. But if it is fusing current, definitely fusing current is like if suppose burning out of that fuse wire, abnormal condition occurs, automatically it will gives disconnection, right? So that is fusing current. So for example, I can say for this 2 amps, this is 2.5, automatically if you reach as 2.1 itself, the fusing element will get disconnect, and fusing factor ratio of this fusing current to the rated current. So it always more than 1, then only that is fusing factor will achieve. I mean, if it is less than 1, the fuse will not get melt. If it is more than 1, it will get melt. And this is the MCB, mini circuit breaker or major circuit breaker. Different kinds of MCBs are using in the electrical point of view. In the laboratory also we are having this type of MCBs. And mini circuit breaker, the cost around the fuse 25 rupees, but MCB cost 120, but it is safety, it is free from hazardous, and it looks good. And fuse elements gives fire hazardous, okay. And MCB only just trip off and then trip on. You can do manual operation also, okay. And next we have an electrical shock. When person comes in contact with the live wire, he may get nervousness, or he may get some mild fever. We can call it as electric shock. See here, what is an electrical shock? So see here, the person is here, and when the equipment's broken terminals is there. So if he is still operating, so the equipment with a high voltage, definitely he may get shock, and then definitely the position till here it will appear, okay. He may get die if it is more shock appears, right. And electric shock, when person comes in contact with the live wire, so definitely they may get a shock, right. 25 milliseconds, 30 milliamps is the withstanding capacity, okay. And domestic wiring, in that we are having effect of electric current on the body. So 1 milliamps, just a faint tingle, I mean just mild fever, mild effect. And 5 milliamps, slight shock felt, disturbing but not painful. Most of the people can let go, however a strong involuntary movement can cause injuries, only injuries, okay. And here 6 to 25 milliamps, painful shock, okay. And freezing current. 50 to 150 milliamps, extremely painful, respiratory arrest it may occur, several muscle contractions. I'll show you next slide how the shock will appear, and then the person how they'll get a shock, and then the body how it will damage, right. So till 10,000 milliamps, definitely cardiac arrest, fever, burns occur, death is probable. So see here, that's why I have given this diagram, okay. Death is possible. This is the diagram, the person got a shock. This is one, okay. And precaution against electric shock now. First of all, do not touch with the wet hands. Use rubber gloves for operating, while maintenance work and all. And while maintenance work, switch off the main supply. If suppose something happened in the electrical appliances or electrical circuits, you must switch off the power supply. After that, you do the repairing work. And use ISO certified tools, whatever the equipment, and broken electrical switches must be eliminated. And earthing must be done properly. Earthing is very important for the electrical appliances while using, right. And well installed tools we need to use, and do not touch the wet hands, already I told you. And you should read the nameplate details. So they used to give some specifications while purchasing the equipments. They'll give that instruction book, right, for the electrical appliances, that you must read. If you give, instead of giving 110 volts, if you give 230 volts power supply, what may occur? So it will damage, right? So that's why you should read the specification, nameplate, everything.